Hi, it's Grant from Dome Music Technologies, and this time we're going to have a look at the ACE Integrator module. It's quite a complicated module to describe, so I thought I would present it over a few videos. In this first video, we're just going to have a look at the most basic functionality of it, and then we'll expand on that in later videos. So if you have a look at the voltage in to the integrator, it's sitting at 0 volts just now, and the voltage out is sitting at 0 volts as well. Now the only way when the integrator isn't running, which would be shown by this red LED, when the integrator isn't running, then the voltage at the output doesn't change, irrespective of what the voltage at the input is. So we bump up the input voltage to 4.9 volts, the output voltage doesn't change at all. Change it to a negative voltage, again it doesn't change the output voltage at all. I'll just put that back to 0 volts. What you can do to change the output voltage when it's not running is to use the initialization function. So you've got this initial volt knob and an initial volt CV input. So if we put the initial voltage up to 1 volt, say, and then we press the initialize button, we'll see the output jump to 1 volt. So there we have 1 volt at the output, and we can see that the output has jumped up to 1 volt here. You can also, you can trigger the initialization manually. So if we just bump this up to 2 volts, then it doesn't change the output immediately until you actually latch in the initialized value. So there we are, it's gone up to 2 volts at the output. As well as the initialize button, there's also an initialize trigger input. So if I just connect this up to the LFO over here, then it should latch in the initialization value whenever the LFO goes high. So wait till it goes low and put in a new initialization value. And it's only when the initialization action starts that it actually latches in that value. And while the initialization input is high, then it will follow the init volt level. So if we just remove that again and set the initial value back to 0 volts and latch it in. So we've got 0 volts at the output, 0 volts on the display, and our Vin is 0 volts. So the gate input is very similar to the initialization one. So you've got a manual button which shows that it's running. You've got a permanent switch which will run for as long as that's set on, and you've also got a gate input. So again, we can put it onto the LFO, and whenever that's high, the integrator's running. What we'll do is take that out, so it's not in its running state at the moment. If we change the voltage input to 1 volts, again, nothing's happening on the output because we're not running. So if I hold down the gate button for about a second, keep watching the output voltage here and here and see what happens. So we've got a 1 volt input voltage and we're on the 1 second time base. So when I press the gate input, the output rises at 1 volt per second for as long as I hold the gate button down. So we're now at 1.9596 seconds, volts at the output. If I hold the gate down for a further period, it climbs up again at a rate of 1 volt per second. So keep on making small increments for as long as I hold that gate down. And because we've got the output limited to plus or minus 5 volts, once the output voltage reaches 5 volts, then it will just freeze there. So I keep the gate held down, and bang, it stops at 5 volts. So we've got two choices here. We can either reinitialize to 0 volts or whatever you've got set on here, or we could change the input value so that it's in a negative voltage. We'll just make it -1 exactly. And that means for as long as we hold down the gate, it will actually fall at a rate of 1 volt per second. So if you keep an eye on the output voltage here and on the display here, I'll start making it go down the way, holding it, holding it, holding it, and that will continue until we reach -5 volts. And when we reach -5 volts, the negative overflow signal gets set, and you'll see that there's 5 volts on that output. And I'll just monitor both of these. So again, if we go back to plus 1 volt input, and we start climbing up from -5 volts, it should take us 10 seconds to go from one extreme to the other. And of course, once we reach plus 5 volts, the positive overflow light comes on, and you've got 5 volts coming out of the overflow signal line. And just go through that again, -1 volts at the input, and this time we'll just put it on to run constantly, and I'll use that instead of keeping my finger on the gate switch. So just keep an eye on the negative overflow signal. So when it reaches -5 volts at the output, the negative overflow gets asserted, and you get 5 volts out of that output socket. So if we just stop it running there, set the V in to 0 volts, initialize it to 0 volts, and if we now run with the V in at 0 volts, the output doesn't change because the rate of change of the output is 0 volts per second. So it doesn't matter how long you keep it running at that rate, it's not going to change the output value at all. Again, you can override the initialization value anytime you want, just by pressing that. And that is the essential action of the integrator. So it changes the rate of the voltage output based on the value of the voltage at the input while it's running. And when it's not running, it will just freeze the output value. And you can override the output value at any point by changing the initialization volt and pressing the initialize button. So I think that's probably enough just to get your head round for the first introduction to the integrator. So I'll pause it there and I'll catch you next time.